This is Lab 5, and I decided to retake a look at projectile motion. Specifically, does launch angle affect range? Introduction. The purpose is to analyze the projectile motion of an object at various launch angles and compare them using experimental data. The 3 experimental videos, each corresponding to a projectile launched at different angles, will be analyzed in Tracker. Note that the system is the mass participating in projectile motion, and the surrounding is everything else around it. So the principle that we're going to look at is essentially, sorry, there's a typo there, but Newton's second law, which then gives rise to an equation that is able to predict range. So specifically, this is the equation. So this model was derived using Newton's second law in 2D kinematics. Gravity causes constant vertical acceleration while horizontal velocity remains constant, and so combining the horizontal and vertical motions gives the range equation, where the bigger the r, the bigger the range, and further the projectile went. Alright, here are the models. So using a protractor to guide me in the launch angle, which I chose to be 25 degrees, 45 degrees, and 70 degrees, I launched the projectile 3 different times, and here are the videos for each of them in respective order to 25, 45, and 70 degrees. Alright, so here are the results, and looking at the X position versus the time graph for each experiment after being analyzed in Tracker, you can see the range the projectile moved in the X direction. So here in this first one, this is at 25 degrees. It ended up having a range of about 0.3 meters. And then here in experiment, sorry, it's supposed to be 2. Right here, yeah, so 45 degrees, it moved 0.4 meters from the start in the X direction. And then the third one is at 70 degrees, and it had the least of 0.15 meters as the range. Alright, so discussion. So as you can see, having seen from the previous slides, the initial launch angle that ended with the biggest range in the horizontal direction is 45 degrees, which is the middle angle between the 3. Okay, so here's some what if and what does it mean. So what if gravity were smaller, like on the moon for one of the experiments? The projectile would stay in the air longer and travel farther regardless of the angle if the other angles were not subjected to a smaller gravity. And what does it mean? Can the results of this experiment be applicable in the real world? Yes, and one case to utilize these findings is in sports. So athletes can improve their performance by optimizing launch angle depending on the activity. So some sources of error, both of them are human errors, just in different forms. So one of them is when extracting data from Tracker might not be completely precise. So like things like setting the point mass in each frame or setting the calibration stick. And then the second one, like when taking the videos, the projectiles likely did not get thrown with the same initial launch force, and so the simulation like isn't uniform. So conclusion, some takeaways. Newton's second law is very powerful and can be derived to give you the range of a projectile in order to see how angle affects the horizontal motion of the projectile. And also that launch angle strongly affects range, clearly from the results. If it's too low, it moves fast horizontally but little airtime, and if it's too high, like the 70 degrees, it's a lot of airtime and little horizontal speed, as you saw with the lowest range. And then the middle angle is the most optimal at 45 degrees, which gives the best balance of both, giving you the highest range. Alright, thank you.